So rotor is rotating. It is a fixed axis. So with respect to the fixed axis, your rotor is rotating. Similarly, your synchronously rotating frame is also starts rotating from this position. So this synchronously rotating speed is fixed speed. It is a fixed speed. So the distance covered by this synchronously rotating frame with certain time we can calculate, which is equal to velocity into time. So if we have a uniform velocity, so it is the, we can say it is the uniform velocity. It is revolving at the uniform velocity. So velocity into time will give the this angle. So this angle is equal to your omega s into t. So from this we have the theta is equal to omega s t plus delta. Your theta is equal to omega s t plus delta. So if you take the first derivative, so it will be equal to d theta by dt is equal to omega s plus d delta by dt. So in case of the disturbance, if there is a disturbance, so means we have some the change in velocity. Earlier our rotor was rotating at a synchronous speed. So means d delta by dt is the change in velocity. So we can say it is the change in velocity omega r minus omega s. It is the change in velocity. Okay? So we can say it is equal to delta omega. So if you take the second derivative, so second derivative is here, this is equal to alpha. Second derivative, or it is the angular velocity. Rate of change is here given the is with respect to the angular velocity. It is the angular velocity of the rotor at which speed the your rotor is rotating. So this is with respect to the change in velocity in time t. So if you take the second derivative, so it will be equal to alpha. Alpha is the derivative. So it is equal to m alpha p m minus p square. So it is equal to m d omega by dt, p m minus p e, or d omega by dt is equal to 1 upon m p m minus p e. So we, when a fault occurs, our objective is to find the value of the delta. During the fault, we have to find the value of this delta and the angular velocity. So at the instant of the fault, here what will be the value of delta, and after this what will be the angular velocity, because at the synchronous speed then it will start reversing. So what will be the maximum value of the delta? So we need to find the value of the delta and omega from this second order differential equation, because earlier we are not knowing what will be the disturbance, how much time the disturbance will remain. So you can have the, here we have considered the acceleration is a constant, but actually if you have your fault is occurring, if you have the two parallel lines and fault is occurring at this position, then you have the other line also, then your this PA is not remaining the fixed. Your PA is not remaining the fixed. It is changing. PA is changing. ठीक है? जेकर fault इधरले पासे पै जाए, तो immediately ये zero नहीं जाएगी. अगर zero नहीं आए, कुछ ना कुछ power transfer खुद ही रहेगी. तो उससे भी fault दे रात तक जेड़ा कर जेड़ा इस तरह का बन जाना है. ਉੱਥੇ ਤਾਂ ਜਿਹੜੀ ਹੈਗੀ ਆ PA ਜਿਹੜਾ ਐਕਸੀਲਰੇਟਿੰਗ ਪਾਵਰ ਜਿਹੜੀ ਹੈਗੀ ਉਹ ਫਿਕਸ ਨਹੀਂ ਹੈ. ਇੱਥੇ ਆਪਾਂ ਕੀ ਆ ਸਿੱਧੀ PM -0 ਕਰ ਲਈ, ਫਿਕਸ ਕਰ, ਠੀਕ ਹੈ. ਤਾਂ ਉਹਦੇ ਵਿੱਚ ਸਾਡੇ ਕੋਲ ਕੋਈ ਵੀ ਐਸਟੀਮੇਟ ਨਹੀਂ ਲੱਗਦਾ ਹੈਗਾ। ਸੋ ਇਨ ਆਰਡਰ ਟੂ ਫਾਈਂਡ ਦਾ ਵੈਲਿਊ ਆਫ ਡੈਲਟਾ ਐਂਡ omega we use some numerical techniques। ਕੁਝ numerical techniques ਅਸੀਂ ਲਗਾਉਂਦੇ ਹਾਂ ਐਸਟੀਮੇਟ ਕਰਦੇ ਲਈ, ਇਹਦੇ ਲਈ ਅਸੀਂ ਐਸਟੀਮੇਟ ਹੀ ਕਰਦੇ ਹੈਗੇ ਆ। ਐਕਚੁਅਲੀ ਸੋਲੂਸ਼ਨ ਨਹੀਂ ਨਿਕਲਦਾ, ਐਸਟੀਮੇਟ ਕਰਦੇ ਕਿ ਇੰਨੀ ਕੁ ਵੈਲਿਊ ਹੋਏਗੀ। ਤਾਂ ਸਾਡਾ ਐਸਟੀਮੇਸ਼ਨ ਜਿਹੜੀ ਹੈਗੀ ਹੈ ਐਕੂਰੇਟ ਹੈ ਕਿ ਨਹੀਂ ਹੈ, ਉਹ 'ਤੇ ਡਿਪੈਂਡ ਕਰਦਾ ਸਾਡਾ ਸੋਲੂਸ਼ਨ ਜਿਹੜਾ ਹੈਗਾ। ਅਦਰਵਾਈਜ਼ ਜੇ ਸਾਡਾ ਐਸਟੀਮੇਟ ਠੀਕ ਨਾ ਹੋਇਆ, ਸਾਡਾ ਸੋਲੂਸ਼ਨ ਕੁਝ ਹੋਰ ਦੱਸੇਗਾ, ਐਕਚੁਅਲ ਦੇ ਵਿੱਚ ਕੁਝ ਹੋਰ ਵੈਲਿਊ ਹੋਏਗੀ, ਤਾਂ ਆਪਾਂ ਐਕਚੁਅਲੀ ਸਿਸਟਮ ਅਨਸਟੇਬਲ ਹੋਏਗਾ, ਅਸੀਂ ਸਟੇਬਲ ਕਿਵੇਂ ਹੋਊਗਾ। ਠੀਕ। ਸੋ ਫਾਰ ਦਿਸ ਪਰਪਸ we use the different techniques to solve the swing equation. Solution of swing equation. We have different techniques. First is known as point by point. Second is Euler's method. Euler's method. Third is Random method. In case of the point by point method, means we have the, on this side we have a time. Here let us suppose our actuating power is changing PA curve. Then our angular velocity is the curve for the angular velocity of the rotor. And similarly, our angle delta is changing with respect to time. So in case of point by point method, which is not in your syllabus, so in case of point by point method, we divide the total period of disturbance into some time periods, into some equal time periods, and we assume the value of this accelerating power during some period remains constant. Earlier, although it is not constant, so during a small interval period, we are assuming that it is remaining constant. So from that, we are calculating the value of omega and delta. In case of the Euler's method, so we have the swing equation which is given by d square delta by dt square Em minus Pe divided by M. So it is a second order equation. So we convert this into the, it is a second order, we convert it into the first order equations. We can convert this into the two first order equations. So two first order equations is, one is the d delta by dt is equal to omega r minus omega s, which is equal to delta, and other is here b omega by dt, which is equal to d square delta by dt square, which is equal to pm minus. So means we have the two equations. Let us suppose we have a function y. Y is a function which is dependent on x and y. Value of y which is dependent on xy function. So we want to update. We want to find a new value of your y. So means let us suppose here one is the t, other is a y. So in case of our case, we have a t. here is the delta, and here is the omega. Okay? Or if we are considering simultaneously, we have the three variables t, delta, and omega. Okay? So this t we are taking the discrete values. We are taking the t in terms of the small intervals. कितने टाइम बाद तुसी लेना है? इधर मतलब t नो तुसी खुद वेरी कर रहे हो. You are varying t अपने लेवल पे, ठीक है? And that yields to your different values of this delta and omega. So in here we can say it is the value of delta or omega. This is the t. So other is a function of y. So how much y value we are getting? How much y value? So initial value of y will be equal to what is the value of x0 and y0. So when let us suppose when t is equal to 0, when t is equal to 0, so our system is under the steady state conditions. Our system was under the steady state conditions. So under that case, we have the value of delta 0. And now this situation we can also find out what is the value of the omega. Or the difference when your machine is under the steady state condition, the omega r was equal to omega s. So difference omega r and omega s is 0. So delta omega is 0. Under that case, delta omega is equal to 0. So then we have to find, let us suppose this is t is equal to 0. Then after the first interval, t1. Okay? So this t1 is equal to t0 plus delta. So we have to find the y1. So means at t1, what is the value of y1? What is the value of y1? So y1 is equal to your f x0 y0 plus Charlie f by Charlie x f x into delta t. So we have, let us suppose we have, this is the function. This is the function. So if you want to find what will be the value of this function or this function after delta t. So we can take the slope here. So this derivative term is giving us the slope. This derivative term is giving us the slope. So if you take the derivative of this equation and substitute the value of your x and y0 at t is equal to 0, then we have some value of this slope. We have some numerical value of this slope, and if you multiply this delta t, we have some this correction. So means the new value of y1 or new value of delta 1 or new value of omega 1 will be equal to the old value of your function plus the correction. So correction is like this. So in case of neutralization method also we have done like this, that we have the function, then fx is equal to your fx0 plus curly f by curly x plus higher order terms by expanding the Taylor series. So first derivative, so divided by first factorial. The second derivative divided by second factorial. Third derivative divided by third factorial. And higher order terms are becoming smaller and smaller. So we have neglected those higher order terms. case of Taylor series, we have neglected those parallel terms. Here also, in case the Euler's method, we are neglecting the higher order terms in order to find the corrections. So means we are finding the new value. We are finding the new value. But we are finding this new value according to the slope. According to the slope. So it may be possible that if you have, let us suppose your slope is and you are taking the derivative like this. So means actual value of the function, if you find here, the actual value of the function is this much. But your correction, you have taken the slope here at this point, and this slope is giving that your function value after E1 will be this value. But actual, you have this value. So means your error, as you are going forward, your error will start increasing. So in order to reduce this error, we use the modified Euler's method. So one is known as a modified Euler's